Hello again. So let's look at our next 3D geometry problem. It says that the areas of the three faces of a rectangular prism are 24, 32, and 36. Find the volume of the prism. So if we can remember, we can make a prism by basically making a square face, or I should say rectangular face, and something like that. Now, to draw the rest of the prism, use solid lines for what you can see on the outside. And we want to have the same dimensions, so like that. And we want something with the same dimensions but in a dashed line, because when we move it, it's going to be kind of behind the prism. Now let's start connecting the other lines. So let's connect this with that, that with that, and going from there, we must connect these two and these two. So now we have our prism, where the dashed lines represent what's behind the figure. So let's think. Three faces of this rectangular prism have different areas. Now, going back to when we covered rectangular prisms, we realized that each pair of opposite rectangles has the same area. So for example, let's label the points A, B, C, D, E, F, G, and H. So for example, let's take one of the bases. So like A, B, C, D. I'm sorry, one of the faces. And it seems like the smallest one, so let's say that has an area of 24. Well, that's also going to be the same area of EFGH, because they're on opposite sides. So then we would have like one of the other faces, EADH, and we can give that one, so that looks like maybe like the medium sized one, so 32. And that also would cover FBCG. Then we're left with the last one, which we could say is ABFE. Which would have the last area of 36. Now, like, why is this important? Well, because all these areas are composed of different things. For example, I could say like DC is the length of this prism, which means that DC, AB, EF, and HG all have the same value, L. Then I could say that HD is the width of the prism, which would imply that HD, GC, FB, and EA all have the same measure, because they would all be the width. And lastly, we would have like EH would be the height, lowercase h, which would be the same for FG, BC, and AD. I know this diagram's got a lot going on visually, but we can tell, alright, the area of ABCD, well, that's a rectangle, that would be the length times the height. Because it has the 3 tick marks, it's congruent with the height. So we know that that is represented by length times height. How about EADH? So EADH. Well, that has the height EH times the width HD. So that is going to be H times W. And then finally, we have ABFE. Okay, so we know that AB would be the same value as the length. AB and DC are congruent. And FB, for example, would be like the width. So you take the 2 dimensions and get the area. So it would be L times W. Now, how is this all related to the volume? Well, we know that the volume is going to be equal to length times width times height. And we have these expressions that are all in terms of length and height, height, width, length, width. So they have the correct values, but how can we get this formula out of what we have here? Well, I noticed that in all 3 of these, there's 2 L's, there's 2 H's, and 2 W's. So, if we multiplied all of them together, like length times height, and multiply that with height times width, multiply that with length times width, well, this can be easily rearranged as, well, L times L is L squared, H times H is H squared, and W times W is width squared. And we know that all that's going to be equal to the actual numerical values. Like, we know LH is 24, we know HW is 32, and 36 for LW. So let's just rewrite it over here. 24, 32, 36. Now, this here kind of looks like that, but how can we get exactly like that? Well, if we just take the square root on both sides, we'll definitely get what we want, because what's the square root of L squared? That's just L. The square root of H squared is just H, and square root of W squared is just W. So we're left over with length times width times height. Now we just have to find out what goes on the right hand side. Well, obviously the square root of 36 is just 6. Now, how about for the remaining stuff? Well, 24 is the same thing as 4 and 6, 4 times 6. And if we're taking the square roots of them, the square root of 4 we know is 2. So we can pull that out as a whole number. Now 32 can be represented by 2 and 16. So, and we remember we're keeping both of those square roots since we're multiplying. We don't need that anymore since we already reduced it. But notice we have a square root of 16, and the square root of 16 just becomes a 4. So now we can get rid of that. So we have the square root of 6 times the square root of 2. But the square root of 6 times the square root of 2 is the same thing as the square root of 12. 6 times 2. And 12 can be broken down as the square root of 4 times the square root of 3. And we know the square root of 4 is just 2, so we're going to multiply by 2 again, and we have a leftover square root of 3. Hopefully that was enough to follow along with. I know the square root stuff can be tricky. Just keep your wits about you. and find those perfect squares so that they can reduce the whole numbers. And now we just have to multiply all this out. So length times width times height is equivalent to, well, we have 2 times 2, which is 4. So, and 4 times 4, which is 16, with a 6 left over. So that would be, well, 6 times 10 is 60, plus 6 times 6, 36. 60 and 36 would be a 96. And then we have a leftover square root of 3. And that gives us our volume, since it's the exact same formula that we need. So the volume of this prism is 96 times the square root of 3. It's a little tricky to get the gist of how to approach it, but if you use your head and see what's going on with the information it's telling you, the real tricky part is just realizing that you have to multiply all these values with each other and then take the square root of that. It might not be so obvious, but hopefully you would see the pairs of length and length, height and height, and width and width, and get an intuition on where to go from there.